All right, this is notes 2-1. It's our first set of notes for the new unit. First off, finding slope. Slope in words, one of the things that we always have to remember when we're finding slope is that slope is a measure of how steep a graph actually is. So if we were to put slope in words, as we did back in Algebra 1, that would be rise over run. It's how much up and down a graph goes, and then how much over to the left and right a graph goes. The formula for slope is dictated by the lowercase m, slope equaling y2 minus y1 over x2 minus x1. The y2 and the y1 and x2 and x1 are just to kind of help us to keep it in order as far as how we plug our numbers in. One of the things that I like to do whenever we're doing that is I label each of them. So for instance, on number 1, -6 would be x, and 2 would be y, 4 is x, 8 is y. These came first, these came second. So now I have them to where I can just plug them straight into where they go in the formula and be able to solve it for slope. So y2 would be 8. Now that minus sign or that negative sign is built in right here to the equation, okay, or to the formula. You have to put that in. You cannot, just because the next number is a negative in certain cases, just put it once. That has to be put down first. So y2 minus y1, which is 2, over x2 is 4 minus, which is built in, x1 is a -6. Anytime I have a minus touching, I just make it a plus. Okay, so now we're ready to go ahead and do the math. 8 minus 2 is 6, over 4 plus 6 is 10. Now we can reduce that. What number goes into both 6 and 10 evenly? And the biggest number that'll go into both of those is 2. 2 goes into 6 3 times. 2 goes into 10 5 times. That is complete. We go ahead and box it, and that we want our slopes in fraction form because, again, that is rise over run. So if we were to graph this one, we are talking a rise of 3 and then a run to the right of 5, okay, which we'll get into later on these notes. Let's go ahead and move on to the next one. X, 2, and then -3 is y. X, y. These came first. These came second. Plugging it straight into the formula. y2 is -3 minus, which is built in. y1 is a -3. Again, a negative, make a positive. Okay, over x2, which is -1, minus x1, which is 2. Doing the math on it, -3 plus 3 is 0, over -1 minus 2 is -3. If we were to put that in our calculator, 0 divided by -3, 0 divided by anything gives us 0. For slope purposes, this is called 0 slope. Okay? And we'll kind of talk about what we can do to kind of keep that one and the next one straight in a second. All right, now number 3, let's go ahead and label it. x1, y1, x2, y2. Okay, so we have y2 is 6 minus y1, which is a -3. Again, we have a negative, which makes a positive. x2 is 2 minus x1, which is 2. And we can kind of see already this is going to come out to the opposite of what just happened. We have 6 plus 3, which is 9 over 0. Now, if you were to plug that into your calculator, it's going to give you an error, or it'll just straight up tell you, depending on the calculator, undefined. Because we can never, ever have 0 in the denominator. This one in particular is saying 9 divided by nothing. 0 is nothing. So nothing does not exist. That is undefined. One of the ways that I like to kind of tell the difference between zero slope and undefined is if you ever went snow skiing or you've seen it on TV, you know that they're in mountains, right? Well, if you're at the bottom, you're standing on a flat surface. You're not actually moving. The only way to move would be for you to wiggle or to use your ski poles to be able to push yourself. So that's a zero slope, okay? Now, also going along those same lines, if you're on those ski slopes and you're going down one of those and you get off the trail and you go over a cliff, that's a straight up and down cliff, well, you're dead, you're gone, that's called undefined. You're no longer defined. So that's another way to kind of keep them straight for zero slope and undefined. They're going to have pictures of, right here, zero slope being no slope at all. It's a flat line. Undefined, so that's a horizontal line. Undefined slope is a vertical line. That's up and down, just like if you went off a cliff. Okay, if you drove off a cliff or you skied off a cliff on a ski slope, you're undefined. Okay, now a positive slope is rising up from left to right. So thinking of it like I'm reading a book from left to right, it's going up. Negative slope is just the opposite. It would be going down from left to right. Okay, so again, a recap. Positive slope, up from left to right. Negative slope would be going down from left to right. Zero slope is a flat horizontal line. Undefined slope is a vertical line. Okay, parallel lines have slopes that are, the best example of parallel lines in the real world are train tracks. No matter how they turn, how they twist, how they go up, how they go down, they always have to stay the exact same distance apart. Otherwise, a train would derail. Now, so that means that each of those train tracks or lines in the case that we're talking about must have the exact same slope. So parallel lines are slopes that are equal. Now the converse of that would be perpendicular lines. Perpendicular lines are lines that intersect, the lines that cross, but they cross in a certain way. They cross perfectly, forming four right angles. So an example of that would be like a plus sign. Okay, that would be a perfect right angle, setting up four right angles, and that would be a perfectly perpendicular lines. Another example of that is your x and y axis. They cross perfectly. One is horizontal and one is vertical. So in order for that to happen, they have to be exactly opposite. And then also, because we're dealing with fractions, they must be a reciprocal. So opposite meaning if one's positive, the other one must be negative. Reciprocal meaning if let's use for example, if one of the slopes was 3/4, the other slope would have to be a negative 4/3. So we call this opposite reciprocal. Okay. Now, on the next one's number 4, we're going to determine whether each of these sets of lines are parallel, perpendicular, or neither. Parallel meaning they have the exact same slope, they're equal. Perpendicular, which would mean they have opposite signs. One must be positive, one must be negative, and they must be flipped. Okay, so again, 4/3 would be flipped and be a 3/4, and it would also have to be turned to a negative. Or neither, which means it's just totally just different slopes. So the first thing again would be just labeling x, y, x, y. These came first, these came second. Line 2, x, y, x, y. These came first, these came second. Okay, so let's just do line 1. Line 1, putting these back into our formula. Y2 is 2 minus, which is built into the formula, y1 is 1 over x2 is 7 minus x1 is 4. So 2 minus 1 is 1 over 7 minus 4 is 3. So 1/3. Okay, so let's go ahead and compare it to the next one. Line 2, y2 is 1 minus, which is built in, y1 is a negative 2. So a minus again makes a plus. over x2, which is 0, minus x1, which is 1. We'll do the math on that. 1 plus 2 is 3. 0 minus 1 is a negative 1. So now we see that they are opposite signs. This guy over here, the first one is 1/3. It's a positive 1/3. The secondary one is a negative 3/1, so opposite signs, and they are reciprocal. So 1/3, the other one is 3/1, so they're flipped. So in this case, this would be perpendicular. And box your answer. Okay, now let's look at number 5. X, Y, X, Y, X, Y, X, Y. These came first, these came second, first and second. Okay, so now on X, the first one, we're going to put in line 1, Y2, okay, this guy here is negative 13, minus, which is built in, Y1 is 1, over X2, which is negative 4, minus X1, which is 3. Negative 13 minus 1 is negative 14. Okay. And then negative 4 minus 3 is negative 7. A negative over a negative makes a positive. 14 divided by 7 is 2. We know that all whole numbers are fractions. We just don't have the 1 underneath it. So it's 2/1. Okay, but you can just leave it 2. Okay, line 2. 5 is Y2. Minus, which is built in, Y1, which is a negative 8, all over X2, which is 6, minus X1, which is a negative 1. Okay, minus and minus make a plus, same on the bottom. So now on this particular one, we have 5 plus 8, which is 13. Over 6 plus 1 is 7. Okay, 13 over 7 cannot be reduced. That one is reduced all the way. If I divided it, it would give me a number other than 2. So we know that this one has totally different slopes. So this one would be neither. All right, number 6, go ahead and label them X, Y, X, Y. These came first, these came second. Same deal on the bottom, line 2, X, Y, X, Y. These came first, these came second. Okay, line 1, Y2 is 36, minus Y1, which is 9, over X2, which is 8, minus X1, which is a negative 1. So we have to make that a plus. 36 minus 9 is 27, over 8 plus 1 is 9. 27 over 9 can be reduced. It can't be reduced, but it can be divided evenly. 27 divided by 9 is 3. We know that if we had to have it in fraction form, that would be 3/1. Okay, but we can just leave it 3 for now. Okay, line 2. Y2 is 13. Minus Y1, which is a negative 8. Again, a minus makes a plus. All over X2, which is 9, minus X1, which is 2. 13 plus 8 is 21. Over 9 minus 2 is 7. Okay, cannot reduce it, but we can divide evenly. 21 divided by 7 is 3. So those would be perfectly they're exactly the same, so they'd be perfectly parallel. Those are parallel lines. So if we were graphing that, it would never ever cross. They would stay exactly the same, going up and over, or down and over. In this case, up and over because they're both positive. Okay, now getting into formulas for the lines as far as what kind of form we're in. Slope-intercept form is when we have our slope and then our intercept. Slope, again, is dictated in math with a lowercase m. It always goes with our x. And then any regular numbers go at the end. Those are my y-intercept. Okay, you'll also hear me call this y equals form. It's because we want to get the y first and then nothing in front of it, so dividing everything out, and then it's just left with y equals, and then we put our whatever our x is, and then our regular numbers towards the end. Okay, so that would be in slope-intercept form. Standard form is our x's go first, then our y's, then our equal sign, then our c's. Our regular numbers. That's why we call it ABC form, is because that just kind of helps us to keep in order of what comes first. There's not actually an A, B, and a C. It just means that A comes first in the alphabet, so that means my X's come first, then B obviously is second, so my Y's would come second, then my equal sign, then my regular numbers, my leftovers. Okay, so we look at number 7, and it's already in y equals form. Notice that in front, we locate our X, and in front of my x is a negative 1/2. That is my slope. I'm going to go ahead and write that down, negative 1/2. Now the negative can either go with the 1 or the 2. That's up to you. If it goes with the 1, that means I go down 1 and over to the right 2, a positive direction of 2. If I choose to put it with the 2, that means I go up 1 and then I go to the left 2. Either way, it will put it on the exact same line. Most people choose to put it with the top and then get it over with that way. The number at the end is my B standing for y-intercept, so it is 2. Y-intercept means it's where it intercepts the y-axis, where it crosses the y-axis. So we're going to go ahead and go on over to our graph, to our y-intercept. We always start at our y-intercept. That's our beginning point. B can also be, you can remember it as a beginning point. So we go up to 2 on our y-axis, and we put a point. Okay, from that point, again, I said most people put the negative with the top, but it's up to you. I'm going to go ahead and put it with the top. So that means I would go down 1, negative 1, because that's my rise. Remember, slope is rise over run. So down 1 and then over 2 and put a point. And I can continue that process. Down 1 over 2, down 1 over 2, and I could do that forever and ever. Now, here's the kicker. If I had put it with the bottom, let's pretend I'd put it with the bottom. I go back to that beginning point, my y-intercept, which is at 2. And that means that the top was a positive 1. So I would have rose 1, but then the negative 2 would have made me go to the left 2. So if I went to the left 2, you can see that if I continued that, up 1 over 2, that it still stays on that same line. So I have a straight line still cutting through. Sorry that my pen is not calibrated perfect, but it would be a straight line going through 2, meaning my y-intercept of 2. Okay. Now on number 8, you can see that it is not in y-intercept form, so I must put it in y-intercept form. So meaning I want my y's first. Right now there is a 4 with my y, so I'm going to write that down, 4y. And clearly I need to get the x across the equal sign. It has to cross, and right now it has a negative 3. So it crosses the bridge, just like we talked about in previous unit. Anytime something crosses the bridge, it changes signs. So in this case, negative 3 crosses the bridge. So we go ahead and put our bridge down, our equal sign down. That negative 3 would cross and become a positive 3x. And there was already a 24 waiting over there. It did not notice that 24 is on the right side of the equal sign. It's still on the right side of the equal sign, so it does not change to a different sign. Okay? Now the last step, I cannot have 4y equals, I want y equals. So how do I get rid of the 4? I divide by 4. Whatever I do to one side, I must do to everything on the other. So I divide everything by 4. So y equals, we want to leave it 3/4. It's reduced. Do not change it to 0.75. If you divided 3 by 4, that's 0.75. We don't want that because remember, whatever is in front of our x is our slope. That is our rise over run. That tells us how much to go up and how much to go over. So we want to leave it a fraction. However, our y-intercept, we always want to make it either a decimal or whole number, however it comes out. This one will come out as a whole number. Okay, because 24 divided by 4 is 6. Go ahead and box it so we know that that is in y equals form or y slope intercept form. My slope, so we locate the x, m, we locate the x, and in front of it is a 3/4. The y-intercept is 6. So now, the beginning point, the y-intercept, that's where it crosses the y-axis, is 6. So I go over to my graph, and I go up to 6. I'm going to make this a little bit bigger. That may help a little bit. Okay, so going up to 6, 1, 2, 3, 4, 5, 6. Put a point. From there, I use my slope to find my other points. It says 3/4, so I'm going to rise 3. 1, 2, 3. Run 4. 1, 2, 3, 4. That's to the right 4. Okay? I can do the same thing going the other direction to get another point because we know that if I go down, that's a negative, and I go to the left, that's a negative. Well, a negative over negative is a positive. So I could go down 1, 2, 3 from my beginning point. So I'm still back at that 6, my y-intercept. Going down 1, 2, 3, and to the left 4. 1, 2, 3, 4. And we notice that those are all on the same line. So when I connect them, it's still a straight line. And I can continue that line on forever and ever, going down 1, 2, 3, over to the left 1, 2, 3, 4, put another point, and I could keep it up and then extend that line if I want to. Okay, I'm going to go ahead and zoom back out. All right. Now it's saying graph the lines using the intercept method. Okay, so it's finding my x-intercept and my y-intercept. Here's the key to this. To find an x-intercept, that means that it's where the line crosses the x-axis. To find an x-intercept, that means my y value at the x-axis, anywhere on my x-axis, the y value is 0. So if I plug in 0 into that equation for y and solve for x, that's going to give me my x-intercept. So for x-intercept, I'm going to plug 0 in for y into the original equation. So I have 3x plus 5, plug 0 in for y, equals 15. And we're going to solve for x. 5 times 0 is 0, so we know that's going to cancel off. And that leaves me 3x equals 15. Now we solve for x. To get rid of that 3, I'm going to divide by 3, both sides. X equals 5. So my x-intercept is at 5 on the x-axis. Now what did we plug in for 0? For y? We plugged in 0. So if I wanted to write the coordinates, I would write 0 in for y, and my x, like we just solved, was 5. So you may see it either way, where I need an actual coordinate for my x-intercept or just what my x-intercept is, which in this case is over 5. So 5, 0, we know that plotting that, and I'll zoom in a bit, would be going over 1, 2, 3, 4, 5, and putting a point. Okay? Now to find the y-intercept, it's just the opposite. Anywhere along the y-axis, my x is 0. Okay, my x is 0, so I'm going to plug into my original equation. I'm going to plug 0 for x. So 3, and my x would be times 0 plus 5, it's a plus, 5y equals 15. 3 times 0 is 0, so it crosses out. So 5y equals 15. Now to solve for y, we divide by 5. Y equals 3. Okay, and if we wanted the coordinates for that, we already know we plugged 0 in for x, and y was 3. So that's over 0 and up 3. So I'm going to go ahead and zoom out. I'm sorry, in. Over 0, up 3. 1, 2, 3, put a point. And all we need is 2 points to make a line. So here they are. And I could clean that up a little bit there. There we go. And that line extends forever in both directions. Okay. All right, moving on. Okay, same deal. We're going to get a little more practice on that same thing. For x-intercept, I'm going to plug 0 in for y. So that would be 12x plus 8 times 0, that's a 0, equals 16. Well, 8 times 0 is 0. It crosses out. So that leaves me 12x equals 16. Now, to solve for x, I'm going to divide by 12. And x equals 16 over 12. I can reduce 16 over 12. The largest number that'll go in this at 16 and 12 is 4. And so 4 goes into 16 4 times. 4 goes into 12 3 times. Okay, so if I were to plug that into my calculator, that would be 4 divided by 3, which would be 1.3 repeating. And that's easy for us to graph. Let's go ahead and still write our coordinate. We put in 0 for y. And 1.3 for x now, because we solved for x. So if I were to go and graph that guy, that's over 1.3. So basically, that's just a little more than 1. So on my graph on the x-axis, I would go over to 1 and then go a little bit more and put a point. So it's not quite a half, but right about there. Okay, zooming back out. Let's go find our y-intercept. Our y-intercept, we're going to plug in 0 for x and solve for y. So we don't know what y is yet. So into the original equation, plugging 0 for x, plus 8y equals 16. 12 times 0 is 0, so it cancels off. 8y equals 16. Solving for y, divide by 8, divide by 8, y equals, when we look and we go, okay, we can reduce that. Not only reduce that, we can divide evenly. 16 divided by 8 is 2. So I put that in to my coordinate. So y equals 2. So again, I'm going to zoom in so that we can get a little bit more exact. Go up to 2. 1, 2. Put a point. And now I have 2 points that I can connect. And that line goes forever and ever, amen, both directions. And that is all there is to it. Okay, I will list the numbers as far as what we're going to do for our homework on our A on Google Classroom, but also we'll announce it in class. So hopefully this helps you to have a better understanding of notes 2-1 and also how to find slope from two sets of points, but also how to find be able to graph with using a slope and a y-intercept, or being able to graph using x-intercept and a y-intercept, and be able to locate both my x-intercept and y-intercept by solving for those. Plugging 0 in for y gives me my x-intercept after I solve. Plugging 0 in for x gives me my y-intercept after I solve. So hopefully that helped out. That's notes 2.1 complete.